Okay, here is an example of another derivation with subderivations, requiring subderivations. So we'll say show conclusion, and it's a conditional, so we'll make our assumption. There are no premises. We would like to apply inference rules, but we need either P and Q or not R, neither of which we have, so there are no inference rules to be applied, so we need to do a subderivation. Okay, well, we're trying to show a conditional, so if we got its consequent, we could box and cancel. So let's try to show the consequent in order to box and cancel the main derivation. So again, this is a conditional, so we can make a conditional assumption. So 4 is maybe part of the way to helping us use 2, but 2, the antecedent is P and Q. We have P, so if we got Q, then we can do modus ponens, and that might be helpful, but with just P, we're not in a position to do modus ponens with line 2 yet, so the derivation remains stuck, which means we need to do another subderivation. So we look, and we notice that we're still line 3, the line we're currently working on, the line we're trying to show currently, is itself a conditional, so we'll show its consequent. Now we're trying to show a conditional, so we can make another assumption. And now we want to say, okay, can we use Q? Now we think, well, the antecedent of 2 is P and Q. We have, on line 4, we have P. On line 6, we have Q. We can put those together to form P and Q with a junction, and we can apply modus ponens now to 2 and 7, which gives us R, and hey, R is the consequent of line 5. Now, so we'll say CD, 8 CD, because 5 is the line we're going to box and cancel, but the consequent is on line 8. Okay, 5 is the consequent of line 3, so we'll say 5 CD, and 3 is the consequent of line 1, and so we'll say 3 CD. So that's pretty straightforward. I do want to show you something about indentation. So you'll see that each time we add a new show line, we get indented, right? So the these two lines are in line with the. So we have this show line. When we move beneath the show line, all the lines indent. When we add this new show line, okay, good. These two lines are in line with each other, but now this is indented beneath there, and the same thing happens here. So you want to try to avoid messing around with indentations. Also, if you look, so right now where line 6 is is selected, and right now 5, the show line in line 5 has a black background. When we move to line 4, we see that line 3 has a black background, and we move to line 2, we see that line 1 has a black background. So what that black background, or I think it's a gold or dark blue background in the gold-blue version, shows you is it shows you which of the show lines you're working on. So right now, we're working on line 5. We've now boxed and canceled line 5, and now line 3 is highlighted, so line 3 is now the line we're trying to cancel. Now line 3 has been canceled, and now line 1 is highlighted, so line 1 is the line we're trying to cancel. So it's helpful if you get confused. You can look at wherever you are in the derivation, and you'll see different show lines get highlighted, and that tells you which line you're working on. And also notice the indentation. Make sure that your lines are indented beneath the show lines. They will be as long as you always are producing new lines from here. But if you start off let's say you had a bunch of here's how we do this. So let's say you had a bunch of lines like this, and then you come back and say show conclusion. These lines are now, note that here line 1 is highlighted, now the whole argument is highlighted up at the top. So if you add a bunch of lines like this, you got to be careful to that the indentation is right. And so it's always helpful to not add a bunch of new lines at once, but to always add new lines as you need them from wherever you need them in the derivation. And then you won't have the problem, then the indentation is taken care of automatically, and you don't have to worry about your indentations getting messed up. So another example of derivation with subderivations. These were both examples of theorems, but of course we can use subderivations for showing arguments that have premises as well, and you'll see that illustrated when we look at derivations with biconditionals, where we will be doing subderivations inside of those arguments even though they have premises. So I hope this was helpful. If you have any questions, please let me know.